Okay, good morning, everybody. I just wanted to start the recording before we start with the lesson. So let me share my screen with you. Okay, so you should see my Jupyter notebook now. And then what I would like to show you, excuse me, is this morning, it's actually today we're trying to do a sort of a quick day because it's been a long week for most of you. It's been a long week for some of the instructors as well. So we're going to do errors and exceptions, defensive programming, and debugging. So we're not going to do the very last part of the lesson because that teaches you terminal, that teaches you some command line stuff, but it's just a little bit confusing if you've been working in the Jupyter notebook and you're a novice. So especially at the end of such a long week. So we're gonna leave that to you. I'm gonna put the link to the lesson material in the Etherpad as well, and you are more than welcome to, on your own time, go and look through it. So on the Etherpad, let me just reconnect you. Okay, I know a lot of us are quite new to the Carpentries. So on the Etherpad on line 17, I'll make it a little bit bigger so that you can see it. On line 17, put a link to our lesson material. Now, I don't know if you know this, but the lessons are free to use. They are open source. You are more than welcome to go through the lesson material at your own time, whenever, wherever you are. And you're also welcome to use the lesson material as long as you cite and say that you got it from the Carpentries. So on line 17, our lesson material is there. The whole Python lesson is there. If you'd like to have the Git and the shell lessons, I'll put them there as well. So you're more than welcome to go through that. And you're also welcome to follow as we go through the lesson material, follow on the lesson material. So today we're going to start with errors and exceptions, and we're going to see if we can make a few errors. So let me just get all of you back on my screen. It's always nice to see the participants and chat. Before we start. Okay, so yesterday you left off with creating functions. So you went through the creating functions lesson for the last part, and I know yesterday was quite intense. That's why we try to have it half days, so you can still go and rest a bit and be refreshed for today. Okay, so today we're going to do some errors. We're going to make some errors, okay, in our case now intentionally, but this is to show us what errors you can get, some of the errors you can get, and how to work with them. So I'm going to make a nice comment here, errors and exceptions, and I'm going to leave it as is. Hopefully I put that correctly. Okay, so every programmer encounters errors. You've seen me make errors, you've seen Stuart make errors, you've made errors yourself in these 2 days. It happens. Most of them are, I want to say, easily fixable, or some sort of easily fixable. Some errors you need somebody to help you, some errors you need to Google, you need to use Stack Overflow, or to be honest, if you see an error that you can't solve, somebody else has seen it before. So that's what's nice about the Anaconda navigator. You can go to Stack Overflow and go ask a question there, or go and look for it. Okay, so all of us will make errors. If you use Python, eventually you'll see some sort of error, and there are different types of errors. So encountering errors and exceptions can be frustrating, and it is sometimes, especially if you are a bit of a perfectionist, you don't want your stuff to work correctly, or you don't really know what's going on, why it fails. And this is why you need to understand different types of errors that you likely can encounter. So now, once you know why you get the types of errors, it's much easier to get the fix. So there are some of us that have been programming for a while that have gotten errors where you sit there for a day and a half trying to struggle and seeing where you can sort out the bug. and you can't find the bug, and it sometimes feels like a hopeless endeavor. But let's see how we can work with this. Now in Python, the error message that you get is in a very specific form, and it's called a traceback. Now, what is a traceback? Let's make an error, and then we can discuss it, and then I'll show you what they mean when they say traceback. Okay, so in this code, it has an intentional error. So I'm just gonna type here, this code has an intentional error. Okay, and what we can do is we type it in, or we can read through the lesson, but let's type it in. Let's do it on a practical way, and then let's see what we can do from there. So favorite ice cream, ice cream. Okay, so make a define favorite ice creams, and then favorite ice cream is equal to square bracket, and then I didn't make the equal sign. I made it dash. So the equals to, and then they put chocolate in inverted commas here. Make a comma, vanilla, and strawberry. Okay, now I know some of the more advanced programmers among us will already see the errors, but let's just carry on with this so we can actually sort it out and work through it before we go to why and how and so on. Okay. Okay, so if you run this code, you will see that the traceback, most recent call last, name error, and then it shows you with these arrows where the errors are, in what line they are, and it also will tell you what the issue is. Okay, so this particular traceback levels, you can determine the number of levels by looking at the number of arrows. Looking at the arrows, you see there's little arrows there. Oh, excuse me, that's where you know where the issue is. Okay. So the first shows the code for the cell above with an arrow pointing at in line 10 in our case for favorite ice cream, and then the second shows us in a function favorite ice cream with an arrow pointing at line 8. In my case, it might be a different line in your case, which is print ice creams. So the very last error, the very last thing you will see, the very last sentence you'll see will actually tell you what the error is. And in this case, it says that name ice creams is not defined. Okay, so this is called a traceback. This is where you can see where the errors are, and in which line they are, and where you can go and fix them. What is nice about the traceback in Python is it tells you where the error is, and it also tells you what type of error it is. So it will tell you in this case the name ice creams is not defined. Now you do get some long tracebacks. In our case, it was only twofold or too deep. But sometimes you might get tracebacks that are 20 levels deep, where you've worked with a specific variable or specific piece of data for a big or large piece of your code, and then the traceback can be very big and very deep. But there are some ways to fix it. Also, it looks like something horrible happened when you look at this traceback, but actually it's just one small thing at the bottom here. You just needed to say that it's ice cream and not ice creams, or actually to go and define ice creams in your code. Okay, so what error does the program actually encounter at the moment? So what you're looking at is an name error. In our case, the variable name is not defined, but you do get a lot of different errors. So if you encounter an error and you don't know what it means, it's important to go and read through your traceback, go and read what it tells you. So that way you can fix the error a little bit faster. And if you encounter a new error, you know what type of error it is, or if you can encounter a similar error, you know how to fix it in a way. So it's also nice to know where your error is, because if you have a long piece of code, it's easier to go and do a specific line. Where in our case, we have a few lines of code, so you can go and fix it quite easily. But if you have a long piece of code, maybe it's hundreds of lines long, then it's always nice to know exactly in which line your error is. Okay, so if you have an error that you don't recognize, there is official documentation. Let me just give you a link to that as well. There's an official piece of documentation. I can show you that quickly. Is the Python, and there's everything that you need to know about exceptions, what you need to know about warning messages, and all of that is already there. What's also nice about this is it's free to use. It's got a lot of different Python versions created in a few different languages. So Python really, the community really tries to help each other and help you figure out your errors, especially if you're a novice or somebody does not use Python that much. So I'm going to put a link to that as well in line 18 of our Etherpad. So it's just Python documentation with a link. So if you have any errors, you're most likely going to find an answer there, or some sort of answer there. If you cannot find an answer there, Stack Overflow or one of the communities forums or so on will also give you a lot of info. Now let's get to specific errors. We get a few different errors. We get syntax errors, variable name errors, index errors, file errors, and so on. So we're going to start with syntax errors. And syntax errors is I almost want to say it's the most common error that I encounter in a lot of different areas, programming areas, especially when you go to R, for instance. Syntax errors is quite common. Now, syntax error is when you forgot a colon at the end of the line, or you accidentally add some white space after a statement, or in your if statement you didn't put proper spacing, or you forgot your brackets or anything like that. That's called a syntax error. So this means that Python couldn't figure out how to read your program, and it's similar to forgetting punctuation when you type in a specific language, or when you write an essay or something like that. So it's similar to forgetting your punctuation. So that's a syntax error. So people can typically figure out quite easily what the error is and how to fix it. So syntax errors in a sense is some of the easiest errors to fix. Let's look at a syntax error that we can define and actually see if we can work through it. Okay, so say message is equal to hello world with an exclamation, print message, and return message. Okay, no, that's actually a space, not a tab. Okay, so if I run this, you will see that it will give you the file where your file is. Line 1, define some function, and syntax error, invalid syntax. So what actually happened here was that in line 1, you forgot the colon. So it tells you invalid syntax, and it also tells you where to go and look for it. So it puts an arrow there, as you can see there, where the issue is. And in this case, it's just you forgot the colon. So actually the function above has 2 issues with the syntax. If you fix the issue with the colon, we'll find another issue. So let's fix the colon and see what the new issue is. So what's the new issue is? Unexpected indent. So what the indentation error is means that the lines should be fixed, and they are not all in the same line. So both this syntax error and the indentation error indicate a problem with your syntax. So both of them are seen as syntax errors, and this means that it's how you programmed your code, what the spaces are, and your punctuation isn't correct. So when you look at tabs and spaces, some indentation errors are harder to spot than others. In this case, it's actually quite easy to see, but some aren't always that easy to see. So in particularly, when you mix spaces and tabs, it's difficult to spot because they're both white space. What this means is if you take your code and you make a tab and a tab, and you space the return like that, it looks fine. It doesn't seem like there's an issue. But when you try to run this code, it will tell you that there's an inconsistent use of tabs and indentation, meaning that if I run this, okay, it's supposed to give an error. Okay, but if you run this, it tells you that there's an inconsistent use of tabs and spaces in the lesson. So let me copy and paste the lesson one. Okay, so there you can see it. There's a tab. As you can see, there's a tab, and these are spaces. So it's actually difficult to see, and it's difficult to replicate, because what Python normally does is will take away the white space and sees it as one white space if you just type. But sometimes when you use tabs and spaces, it will then give you an error. Now in Jupyter Notebook, it replaces the tabs with spaces. In some of the Python IDEs, and if you use it in command line or in terminal, your tabs and spaces won't be the same thing. But in Jupyter Notebook, they took away that issue, in a sense that they replaced the tabs and spaces just with the same white space. Okay, so if you program, remember that your spacing and all of that should be the same. If it's not the same, it is seen as an error, and it's specifically seen as a syntax or indentation error. Okay, now we get to variable name errors. What does this mean? Any other programming language that you've used before, you will hear that people talk about case sensitivity. Some programming languages are case sensitive, some aren't case sensitive. In Python's case, it is case sensitive. Now, when we get to variable name errors, there's a lot of things that come into play here. So a very common error is when you want to print a variable that does not exist, for instance. You have not defined it yet, and you want to print it. You saw me do that on Wednesday. I wanted to write a function called data, but I never defined data before, and that gave me an error. So if I just say print A, it will tell you that on that line, in my case now line 2, because I left a comment in there, that name A is not defined, meaning that we don't have a variable called A. So variable names and errors come in a lot of different ways, and they are, luckily the messages are very informative, and they will tell you that this is not a variable name, it's not defined. So this is going to depend on how you program and how you work with your programming, and how everything folds together at the end of the day. So if you want to print a string, for instance, as well, and you forget your inverted commas, it will also give you the hello is not defined. So if you want to print hello, for instance, you have to remember the inverted commas, and that will print properly. But if you forget them, it will see that sentence or your string then as a variable, and it will tell you, but listen, I don't know this variable, I cannot print it for you. Okay, so things like that to remember. If you don't define a name, and if you forget your inverted commas, it will be a variable name error. But the inverted commas is also sort of a syntax error, but in Python sees it as you want to print a variable. Okay, so coming back to our loops, you did loops yesterday. So if you look at a loop always has a counter. So if we have a for loop here, so you say for number in range 10, there you go. You want to count, say you want to count from 1 to 10, or you want to count from 0 to 10, and you say count equals to count plus number, so it will then add a specific amount in every iteration. So print, and you say the count is, and you say count. So this will give you an error. Why? Does anybody know?
We didn't define what count is.
Yes, you don't know what count means. So even you run this, it will tell you that count is not defined. Now this is something that happens sometimes when you are in a hurry, or you think that you already defined your count. Now, if you look at all the ways of programming, like I start with Turbo Pascal, for instance, you have to define your variables at the very top of your function, or the very top of your program or script. As well as in Java, sometimes you define some of your variables, global variables, at the start. Now, it can happen when you think that count maybe is a global variable, not just a local variable. And then you just carry on. And when you run your program, you might be quite, I want to say, taken aback that, whoa, I did use count, but what's happening here? Okay, so just remember to define everything as you go along. Another error that can happen is a typo. For instance, if you define count, but you define count with a capital C, and I run this, it will give you an error again saying that count is not defined. Why? Because Python is case sensitive, and count with a capital C and count with a small cap C is not the same thing. It sees it as two different variables, and it will not work. Okay, so remember two things: case sensitivity, and make sure that you define your variables before you try to use them. Okay, and then the last part of, oh no, it's the second last part. The next part is the index errors. Now, index errors are quite interesting. It mostly has to do with containers. Index errors, there you go. And specifically like lists and strings and the items within that container. So if you try to access an item in a list or string that does not exist, then you will get an error. Now, it makes sense, because if it does not exist, then you cannot call it up. It's frustrating for you if somebody calls you by another name, or somebody continuously spells your name wrong. It's as is with Python. If you continuously ask him for something that does not exist, it will tell you, listen, it doesn't exist. Okay, so let's see how this will work. So the index errors is you define a list, and it's A, B, and C, and you tell Python to print Dr. Srikan, do you have a question?
No, actually, I joined late today because we had a meeting this morning. So
Okay, no
I'm
problem.
sorry. I'm sorry for it. Okay.
No
Just
problem.
joined. Yeah. Thank you.
Welcome.
You can continue. Yeah.
Okay, so sorry, now I'm typing in the chat again. You want to print letter number 1 is, and then you say, you go back and say it should be letters 0, and you want to print, I'm just gonna copy and paste this because why not? So you want to print number 2, and you say it should be letter number 1 or in position 1, and you print number 3. Oh, I'm making typos in my string. There you go. That's better. And it should be in position 2. Christel, do you have any questions?
Yes.
Yes.
I was wondering if you can maybe still go back to line 11, how to fix it, because I didn't figure out.
Okay, no problem. And in our case, the first thing that happened in this case was we never defined count, and then we defined count wrongly. So what you to do here is to make sure that your count is the same across your loop. So you have to make it was like this with a capital C. So if you make a small cap C and you say for number in range count with the small caps equals count plus number in the small caps, and you run it like that, it should run then from 0 to 45. Okay.
Thank you very much. Okay.
No problem. Okay, so coming back to our index error, we said that the index error has mostly to do with containers and lists. So in our case, we made a list called letters with 3 entries, 0, 1, and 2. And now we want to call up more than what we have. So this happens sometimes if you maybe don't remember that Python starts at 0 and not at 1. So you think in your mind, maybe think 1, 2, and 3. And if you run this, you will see that we get an error. The name letter is not defined. Okay, sorry, that's my fault. That's a typo. That's not the lesson. That's a typo. So let's do that again. Okay, this is the error that we actually wanted to see. Now, if you look at your output, you'll see letter 1, letter 2, letter 3 is A, B, and C. So letter 1 in position 0, which is A, letter B, which is in position 1, which and letter 3, which is C, which is in position 2. And then it tells you, listen, there's another line here that I don't understand because the list is out of range, meaning that there is nothing in position number 3. So what you can do is you either take out that line or you give it a position. You say that's D. And if you run this again, then it will give you A, B, C, D. Okay, so something to remember is that your range can also run out, and then like we've been saying the day before and the day before yesterday and yesterday, that Python starts at 0 and not at 1. Okay, so the next part that we have is file errors. Now, file errors is associated with reading files. Now, some of you have seen the file not found error. If you try to read a file that does not exist, or you try to read a file that does exist, but you're not in the right directory, you sometimes get this error, and it will tell you that, listen, I don't see this file. This file does not exist for me. So how do I work with something that does not exist? And in Python 3 specifically, will return an unsupported operation error. More generally, it is input and output error depending on what version of Python you use. So let's look at some of these file errors. Okay, so we're going to try and handle a file, and we open it, and the file is called myfile.txt. And we handle it with R. So if you run it, it will tell you that, listen, in this file handle piece of code of yours, it says that you wanted something called my file. Now there you get a file not found error, and no such file or directory, because the file does not exist. Okay, so how do you fix that type of error? Please make sure that you are in the right directory. You saw Stewart going to data slash inflammation.csv or inflammation.png or whatever file you need, and make sure that the file name is correct. Make sure that the file actually exists. So you can go and double check in your directory what you're using. Is there such a file? If not, then you know that you are in the wrong file. If there is such a file, make sure that your spelling is correct, and then make sure that you are in the right directory. Okay, so sometimes you will have to specify the whole directory like you did yesterday. So in my case, it should be something like desktop / and then what did I call it? SWC 428 April 2022 / and then your file. Okay, so those are a few things to remember. But okay, my file does not exist now, but it's just sometimes you can just call up the file because you're in the right directory. Sometimes you have to go one deeper or one up. It depends on how you use your system. So if you look at this, some issues that can happen also is that you want to use the read flag instead of the write flag. So Python will not give you an error if you try to open a file for writing. It will just tell you the file doesn't exist. So when we look at this, let me just fix it. When you look at this and you say, okay, open it for me. We try to open it readable, and we want to open it writable. And we say file _ handle dot read, and we put in our brackets. It will tell you that the file is not readable. Okay, so it will depend on what type you want to use and how you want to use it. So if you want to open it for just to read it, make sure that you put in the R flag there. If you want to open it to write in it, to work with it, open the W flag there, and it will not tell you the file doesn't exist. In this case, it will tell you, listen, it's not readable, meaning that there can be two errors. Can either be the file does not exist, or the file exists but we cannot read it, so you won't be able to write to it. Okay, so the next part is a few exercises. So it's quite difficult to copy and paste in the Etherpad. So what I'm going to do is I'm going to give you the link to this specific part of the lesson and ask you to scroll down to the exercises. So let's just do it like this. Day 5 exercises. If you hear a guy with a saw at the background, I'm really sorry. Somebody's chopping down some trees outside. I don't know if it's the municipality or somebody. Okay, so in line 584, I'm going to make it a heading 3 so you can see it. In line 584 of our Etherpad, in green, you will see that this is a link to our exercises, and when you click on that link, it should open this part of lesson errors and exceptions. Please scroll down just underneath file errors. You will find that there are a few exercises. The first one is called reading error messages. Read the Python code and the resulting traceback below and answer the following questions. So you don't need to physically go and type it into your notebook. You're more than welcome to go copy and paste it and then read it in your notebook. But they gave you the error here as well, so you can read the traceback. And it says, how many levels does the traceback have? What's the function name where the error occurred? On which line number is the function in this function that the error occur? What is the type of error and what is the error message? So it's, you have to go and examine this traceback and tell them what the error is. Now the solutions are there, so please don't cheat. Maybe if you go directly to the solution, you're just cheating yourself. And then identifying syntax errors, read through the code below without running it and try to identify what the errors are before you run it. And then they ask you run the code and see what errors you get, fix the errors, and then repeat 2 and 3 until you have fixed all the errors. Then they say identifying variable name errors, read the code and without running it, try to identify what the errors are. Then they say run the code, look through it, see what the errors are, fix the errors, and repeat the steps until you have everything fixed. And then identifying index errors, read the code below, and then run the code and fix the error. Okay, so I'm going to give you 20 minutes for this. It's 20 to 10 now. And then at 10, we can discuss it quickly before we move on to the next part of our lesson. So at 10, everybody be back at 10. And please go and do this exercises for us.
Okay, please post the link of the Etherpad on the comments again.
Okay, the link to Etherpad is in the chat. You should see it now.
Thank you.
Okay, no problem. Okay, so let's look a little bit at our our exercises. So the first one is reading error messages. Let me just throw it up here. Now, when you look at reading error messages, it says read the Python code and the resulting traceback below and answer the following questions. So the code goes through Monday, Tuesday, Thursday, Friday, Saturday, Sunday, and print messages day, and then print Friday message, print message Friday. Okay, so what the error is, the traceback gives us, there's an error in line 16, 14, 11, and the key error is Friday. So how many levels does this traceback have? When you look at this, I can already see it looks like it has 3. And then they ask you, what's the function name where the error occurred? So when you look at this, it is the print message. We see print Friday, print message over there. And then they say in which line number in the function did the error occur? In line 11. Print messages day. Oh, sorry, that's my mouse that went haywire there. So when you look at print messages day, the issue was Friday. Okay, and then what's the type of error? It's a key error. Don't know why it's keep on doing that. It gives you the name of the error, key error, and then what's the error message? The error message is there isn't just, it just says key error Friday, so there's not really explanation message. Okay, so identifying syntax errors, read the code below, and without running it, try to identify what the errors are. So when you look at the code, what does the error have? And then it looks like there's few syntax errors. For instance, if you look at this, another function, there's a few syntax errors over there. And then you say run the code and read the error message. Is it syntax error or a indentation error? Now it looks like both to me. When you look at your original piece of code, there's some indentation errors there as well. And when you look at your another function, there is a syntax error there. So it's both of them. And if you want a fixed version, you can find it here in the solution. So it's over there. You see that the brackets and your colon is in there, and the print all line up properly just under A. Okay, so that makes sure that the indentation is correct. Okay, so the next one is identifying variable name errors. Read the code below without running it, try to identify what the errors are. Now, when you look at the code here, number in range 10, number, what's that, 3 equals 0 message. Okay, so it looks like we have one variable that's not defined, and that will also give you an error there. So what's the 3 name error? For number being misspelled, and for message not defined, and for A not being in quotes. Okay, so that's syntax errors as well, variable name errors. So as you can see, these type of errors always coincide in a way. You can make a syntax error on your own as well, and a variable name error on your own as well, but a lot of times they go together. And then they said run the code. Okay, we saw the code and we fixed it, and repeat steps in 2 and 3. Okay, so there were 3 errors there. There's a way that you can either do it all together, or you can go step by step, depending on what you would like to do. Then the next one is identifying index errors. Read the code below, and without running it, try to identify what the errors are. As you can see here, there is spring, summer, fall, winter, meaning we have 0, 1, 2, and 3. And they say print my favorite season is season 4. So you will get an index out of range error. And what type of error is this? It's an index error. And they say fix the error. So you should either, as you can see, they say -1, or you can say 3. Okay, so that was the exercise. Let's take a 10-minute body break. Go get some coffee, stand up, walk around a bit, get the blood flowing, and then when you come back at 10:15, then sorry for that. Then we'll do defensive programming. So let's take a 10-minute break and then be back here at 10:15. Okay, welcome back from the break. I hope you got some coffee, got some water, and feeling refreshed. We're almost done with the workshop. We just have an hour or so left, and then we should be done. Okay, so the next part of our lesson is defensive programming. Now, what does it entail? In the lesson up to now, we've introduced a few basic tools: variables and lists, file input, outputs, loops, conditionals and functions. And what I haven't showed, what we haven't done yet, is after you've written a program and you see it executes, how do you know it gets the right answer? How do you know it still gets the right answer if you've worked on it, if you've augmented it a little bit? So to achieve that, we need to write a program that checks the operation, a program that runs tests for widely used functions, and make sure that we know that we're getting the correct answer. But to get that, you have to know what the correct answer actually is. You have to know what it should be, what it should do. Okay. To start then is assertions. Now, what is an assertion? Assertion is the first step towards knowing if you're getting the right answer from your programs. And the way you do that is to assume that you will make mistakes, and mistakes will happen, and there will be some errors in your coding. So this is called defensive programming, and the most common of that is an assertion. Assertion. I don't know how the pronunciation is in the different languages, but yes, an assertion. I'll show you the spelling so you can. There you go. That's a spelling. So I don't know. I know a lot of different English accents will call it something else, and people's pronunciation will be a bit better than mine. Okay, so it's simply a statement that something must be true at a certain point in your program. So when Python sees this, it evaluates this condition, and if the condition is true, it continues with the program. But if the condition is false, the program stops and you will get an error message. So it will halt the program immediately if there's an error. And let's show you a practical example. So let's make a list, and we say numbers equal to 1.5, 2.3, 0.7, minus 0.001, and 4.4. Okay, we can make it a little bit better. Let's make some white space so it's not that crowded. Okay, now what we want to do is we want to make sure that we only use positive numbers. Okay, so we define the total as 0.0, and we say for num in numbers, please do the following. Assert that the number should be bigger than or greater than 0, comma, if not, give me this error message. Data should only contain positive values. So once this loop gets to a negative value, it will then stop and tell you, listen, your data should only contain positive numbers. And then we say total plus equals to num, so total will increase with every iteration. And then we want to print the total. Total is, comma, total. If you run this, you will see that you will get an assertion error, and the assertion shows you with my typo, the data should only contain positive numbers of positive values. Now, what does this tell you? It tells you that you're testing your own data and you're making sure that data is correct. Now, this could have been avoided by just taking out the minus, but when you're working with data that you import, you don't always know if the data is the way you would like it to be, and assertions, but this assert will then help you with that. Now, programs like Firefox, for instance, have a lot of these assertions in it. You'll get a lot of error messages if you've seen some of them. And you will, like, for instance, a file not found error or a 404 website not found error, stuff like that. So that's also part of an assertion. Now, 10 to 20% of the code they contain are there to check the other 80 to 90% of whatever works. So that's a way of testing. So about 10 to 20% of your code helps you test 90% of your code. Now, assertions fall into three categories. Precondition, which is something that must be true to start of at the start of a function in order for it to work correctly. A post condition is something that the function guarantees is true when it finishes, and an invariant is something that is always true. Now, to test this or to show this, we're going to use a tuple with 4 coordinates, and we're going to the lower left and upper right corners of a rectangle in order to do some calculations. So we need to normalize this rectangle. So the lower left corner is at the origin, and the longest side is 1 unit long. So this function will do that and see if the inputs work and so on. So it's quite a long, and so I'm gonna type as good as I can. And make sure we don't make typos. So say normalize rectangle and direct. What one? Take out that white space. And there's going to be a few of these inverted commas, and we're gonna say this is to show us what it should do. So normalize a rectangle so that it is at the origin and 1 unit long on its longest axis. Okay, then the input should be of the format x0, x1, y0, and y1. Now the mathematicians among us should recognize this. Then they say x0 and y0 and x1 and y1 define the lower left and upper right corners of the rectangle respectively. Ooh, okay. Okay, so that's what the function is supposed to do, and let's see what you can do. So what we do is we assert that the length of the rectangle is equal to 4. So this is a test, it's not an assignment, it's a test. And then we say rectangle must contain 4 coordinates. So this is to make sure that the rectangle always has 4 coordinates, x0, y0, x1, and y1. Okay. Then we say x0, x1, y0, and y1 is equal to, so now we assign it to rect, which is rectangle, and then assert that x0 must be smaller than x1, and we assert that y0 must be smaller than y1. What we do with the first one is x0 must be smaller than x. It's not, you get invalid x coordinates. Then if y0 is not smaller than y1, we get invalid y coordinates. Okay, now we do the actual test. We say dx is equal to x1 minus x0, and we say dy is equal to y1 minus y0. Then we say if dx is greater than dy, do the following. Scale equals to float dx divided by dy. Okay, so the upper x and the upper y is equal to 1.0 scaled. Remember, we're scaling as so the coordinates are correct. Else, we don't want to get an indentation error there. Scaled is equal to the float of dx over dy, and the upper x and the upper y is equal to scaled, comma 1.0 and not 1.0 comma scaled. Okay, now we test again, and we say assert 0 should be smaller than the upper x, which is smaller than or equal to 1.0, and if not, we say calculated upper x coordinate invalid. And we test again, and we say 0 should be smaller than the upper y, which should be smaller than or equal to 1.0. And if not, we say calculated upper y coordinate invalid. Okay, and then we should return 0, 0, upper x, upper y. So in the other case, x0, x1, x0, x1, y0, y1. Okay, so let's see, 0, 0, upper x and upper y. That's a big typo. That will not work. There you go. Okay, so this, when we run this, excuse me, it will then, it's supposed to normalize the error. So the preconditions on line should be looked at, and we make sure that we run everything properly. So if we print the normalize rectangle, and we say 0, 0, 1.0, and 2.0, we should get an error because we don't have a missing coordinate. We don't have a fourth coordinate, so we have a missing coordinate. So let's see what happens if we run this. So it tells you that the traceback tells us there's a error in line 1, and then it tells you on line 5 this rectangle must have 4 coordinates, and it tells you, listen, I want 4 coordinates. You only gave me 3. I want 4 coordinates. So how do you fix this? You add the 4th coordinate. Now, if you go and you look at the assert that says the upper x and upper y must be bigger than 0 and then must be smaller than or equal to 1 coordinates, then it means that if you give them bigger coordinates, it won't necessarily work. Now, in our second assertion also says that assert that x0 should be smaller than x1, meaning that the origin should be smaller than the endpoint. Now, if we do this and we make this the origin larger than the endpoint, then that assertion should work. So it should tell us, listen, there's an error. So normalize rectangle. I don't know why they gave long names. When I code, I rarely give it names that are that long. Okay, so now we say that x0 is 4, x1 is 2.0, and we keep with y0 is smaller than y1. Let's see what it does. Okay, it tells us that invalid x coordinates, which is fine because we say we inverted the x coordinates. The x-axis actually inverted, meaning that our origin is larger than our endpoint, which means that the rectangle is moving in the wrong direction, which is wrong. Now we can test off our insertion for the y coordinates as well. But these are all things that we put in place to test ourselves to make sure that we code correctly. So that's the way assertions help us within our programming and help us to make sure that everything is fine. Now, the post conditions that we have catch bugs telling us that our calculations might be incorrect, but if we normalize a rectangle that is taller than it's wide, it looks okay, but it should not be okay because a rectangle should have, it should be exactly the same. So if we normalize it, the assertion should be triggered if we say wider than it is tall. But if we say taller than it is wide, it looks like it works. So let's see that. So normalize rectangle, and we say we keep our x-axis. Wait, that's a. Oh, there you go. X-axis we keep at 0. Then we make y1 y0 bigger than y2 or y1, and we see what it does. Okay, so it tells you invalid. It should tell you invalid y coordinates. Okay, so it tells us invalid x coordinate still, meaning that it wants this x1 should be bigger than x2, x0. Okay, so let's make that a 1 and we see what it does. Now it should tell us invalid y coordinates. Okay, I have a little typo there, meaning that our assertion works. So that's a way that you can test if your code works or not, if your code gives you the correct answers that you're supposed to get. So assertions aren't just there to catch errors, it also helps you understand your program, and it gives you, if you write a piece of code and you give it to somebody else, it helps that person read through your program and it helps them to check if the program works correctly. It also helps yourself if you come back in a week or two to see what you did and you forgot a little piece of your code or so on, or you can't remember your train of thought, which happens to me all the time. It helps you to get to the same place where you were. So the most, I want to say, programmers that have done it before, a little bit of intermediate knowledge about programming, have things that they call fail early, fail often. We're going to talk about it a little bit. That's a way of testing your code. So there's a lot of ways to put that in place and make sure that your code fails in a way so that you test if your code works properly. So assertions help with that, and there's a lot of other things as well. So the second rule that they also follow is turn bugs into assertions or tests. So whenever you fix a bug, put in an assertion so that if you make the same mistake again, you can catch it early. So you don't have to go through the whole program again, take a few hours to sort out your bug. So assertions always help to check if you did not regress, meaning that you didn't include new problems or old problems that you already fixed when you fix new bugs. Sometimes it happens when you have a large program. In order to fix one bug, you create another bug. It happens. Okay. Any questions until this far? I know this was quite mathematically intense, but it's just to show you that the insertion test a specific thing. So if you don't understand the whole normalizing the rectangle part, this whole part, don't feel discouraged. It is a little bit more on the mathematical side of things. Okay, so our next part is test-driven development. Test-driven development. Test-driven development, also short for, I think, TDD, is to help you look at your code and sort of get your code to run quicker and faster and better and all that. So an assertion checks that something is true at a particular point in the program. The next step then is to check your overall piece of code. So to make sure that it gives you the right output when you want to output, and to make sure it does what it's supposed to do, you need to find a way of testing it. So one way of testing it is, we have an example here, is suppose you need to find where two or more time series overlap. The range of each time series is represented as a pair of numbers, which are the time intervals started at and ended. So let me give you a picture here so you can actually have a clue what I'm saying. So the picture looks like this. Okay, I hope you can see it. It's quite small. So the above time series starts at -3, it ends at 5. Then you have a 0 to 4.5. Then you have a -1.5 to 2.0 and a 0.0 to 2.0. Now, what they would like to do here is to get the range where these time series overlap each other. So they say here most novice programmers, which are most of us, would solve a problem like this. They write a function called range overlap. They call it interactively on 2 or 3 different inputs, And sorry, if it produces a wrong answer, they fix the function and rerun the test. Now, it will work if you do it one by one and fix the errors one by one. But what they would like us to do is write a short function for each test, then, and write the range overlap function that should pass all of those tests. And if it produces the wrong answer, fix it and rerun the test functions. So writing the test before writing the function is called test-driven development. Now, what they mean by that is a lot of times you look at a issue and you go and write the function that will solve that issue. So in this case, maybe a for loop that will run your test and make sure everything works, or you just make a function that will run the test and see where everything overlaps and give it to you. But what they say here is that if you write your function before you write your test, meaning that you have to test for yourself where does what overlap here. Now, if you write the function before you do the test, and a lot of times you run the test to sort of validate your code, meaning that you go into a coding bias, which will then not necessarily give you the correct answer. Now, what they suggest then is you write the test before you write your function to make sure everything works. So there are three functions for this then to test if this overlaps, which they give us. So I'm going to put them back. I'm going to go back to our Jupyter notebook. There you go. Right, test-driven development. So what we do is we're going to put the assertions before we do the function. So remember, assertions is to test if your code is working correctly. So let's call it range overlap with an underscore. And we say we test then if 0.0, 1.0 is equal to, sorry, there's a typo there, 0.0 to 1.0 is equal to 0.0 and 1.0. The second that we put in for range overlap is 2.0. Sorry for that. There should be brackets here because you're not making a list, you're testing. Okay, so put a bracket here as well. From 2.0 to 3.0. And then from 2.0 to 4.0, where will the overlap be? The overlap will then be between 2 and 3 because 3 to 4 does not exist, or they don't overlap at 3 to 4, but they do overlap at 2 to 3. So the overlap will then be at 2 to 3. So then that will be equal to 2.0 and 3.0. And then we assert that the range overlap between 0.0 and 1.0, as well as 0.0 to 2.0 and -1.0 to 1.0. Okay, so where do these overlap? They overlap from 0 to 1, because that's the only place where all of them will be able to have the same value. So
Sorry,
yes,
I think you forgot a comma on the second point. supposed to, is it supposed to be 0.0, comma 2.0?
Okay, thank you. There you go. That should work. Okay, so where do these overlap? They overlap at 0.0 to 1.0. Okay, so why are these float numbers? Because they are coordinates. They aren't necessarily just integer numbers. Now for this, I'm going to get an assert error, meaning that the range overlap's not defined, or you will get some other errors as well. You should get an error at this point because there's no function yet. So getting this error is actually half reassuring because nobody has written the range overlap test yet. If somebody had written it and defined it, you wouldn't have the error. So range overlap would exist at this point. So something important we still miss is we don't test if there's no overlap at all. We just test if there's overlap. When you go back to the picture, at the moment we're testing the overlap. So we're not testing if they do not overlap at all. So what we can do then is we add a assert and we say, what are we going to say? What if there's no overlap? Because if there's no overlap and you run a range overlap function, you might get an error or the function will stop. It will not necessarily work as you would like it to work. So to do that, there is something called none. It's built into Python, that means there's nothing there. Some other languages use null or null. They also use not available in R, I think NA. Not available in R is predefined. So in Python, in this case, we have something called none. So what we can add then to our code here is another assert where nothing overlaps. So the first three is something overlaps, and the last two is then nothing will overlap. So range overlap. And then we say 0.0 to 1.0. And the other coordinate is 5.0 or 5.0 to 6.0. And nothing overlaps there because the ranges are just not overlapping each other. There's nothing there. So you say none with a capital N. That is a predefined function that you can just use. And then our second one is range overlap is 0.0 to 1.0. So it starts at 0.0 and it ends at 1.0. And the other function starts at 1.0 and ends at 2.0, meaning that it just miss each other. And none. Okay, so these assertions then will test if you have tell you where the overlaps are. If you don't have overlaps, to tell you there are no overlaps. So we can try and run this again, but we will get an error. It should give us an error. That's fine because there's no function yet. And then let's write the function now. So now we know the test that we have to run. We know the assertions that we have to put in place. And what we want to see is where do these ranges overlap? Okay, so let's write our function and we call it range overlap. And we define ranges. And then what we want to see is we want to return the common, returns the common overlap among a set of ranges. We can say left, right ranges. So meaning you sort of a ruler, you're going from left to right in a two-dimensional space. Okay, so
Okay.
So what we're gonna do is we define that the max left is equal to 0.0, which we saw on the picture. So the max left is 0.0 and the minimum right was 1. Okay, so they defined the maximum left you can go and the minimum amount of space you can go to the right. And then, so you can't go from 0 to 0, you have to move. Then for left, right, in ranges, we say that the max left is equal to the max of max left. And we say that the minimum right is equal to the minimum and right. Okay, so what we want to return then is the maximum left and the minimum right. Okay, so what are we calculating here? We're calculating the left endpoint of the overlap as the maximum of the input of left endpoints, and the overlap right endpoint as the minimum of the input right endpoint. So we'd now like to rerun our tests, but they're scattered across our cells, so we have to define them as test range overlaps. Let's run this function first, and then we define our function as test range overlap. And then we add our assertions that we did. So I'm just gonna copy and paste them here. There you go. Ooh, just make sure our indentation is correct. And now we can run this. So let's run this as well. And then we can call up our test range overlap function. Okay, so let's call our test range function. Test range overlap function. And we get an error. So why do we get an error? It tells us that assert overlap none, or the first, actually in our case now, the one that says 2 and 3 gives us an error. Now the first test was supposed to produce none fails, so we know something is wrong with our function, and we don't know whether the other test passed or failed because Python altered the program. So as soon as it sees the error, it altered this program. So there are still some information that we can use. So some information is better than none. And if we test the behavior of the function with our input, we see that the initialization of max left and minimum right, okay, sorry, we see that we initialized the maximum left at 0 and minimum right at 1, respectively, regardless of our input values. So this violates another important rule, is that we have to initialize from our data. So we gave you data, and we were supposed to use our data that we had to work on that. Now, I know this part of the lesson is always a little bit confusing because it's quite a, I want to say, intensive part of a lesson at the very end of a long week. But to understand this, you have to go through all the other parts of the lesson and so on. So we have a few exercises again where you can test your assertions and test your pre and post conditions. So I'm going to give you the link again to our lesson, and I'm going to put it in Etherpad. If you don't have the Etherpad, the link is in our chat. So exercise 2, and DDD, and there's the link. Okay, so what it says is, let me put this on your screen as well. Suppose you're writing a function called average that calculates average numbers in a list. What preconditions and postconditions would you write for it? Compare your answer to your neighbor's answer. Okay, we're not going to do that. We're just going to keep this, see what you can come up with, and then see what we can do there. Okay, I see there's a question in the Etherpad. Can you re-explain assert range overlap 0 to 1, 0 to 2, and minus 0 to 1 is equal to 0 and 1? Okay, now if you look at a linear line, there should be 3 lines then there, 0 to 1, and then 0 to 2. In other case, they're going to overlap at 0 to 1, because both of them are going from 0 to 1 at least. Then you get one that goes from minus 0 to 1, meaning that they all overlap at, they start overlapping at 0.0, because the minus 0 to 1 goes from minus 0 through 0 to 1. So all of them, where they overlap, is the piece that says 0 to 1. I hope that is a good enough explanation. Okay, so coming back to our exercises, the next part is testing assertions. Giving a sequence of numbers of cars, the function get total cars returns the total number of cars, and they give you some code there. Explaining words what the assertion in this function checks for each one. Give an example for input why that assertion will fail. Okay, so please do that. It is almost 11 now. So I'm going to give you, say, 10 minutes to do that. And then when the 10 minutes is done, then we can go through the answers quickly and then do the very last part of our lesson, which is debugging, which is more or less just me talking a lot for another 20 or so minutes, and then we should be done for the day. Okay, so I'm going to give you 10 minutes for that and be back at 11:10. Okay, so let's have a look at our exercise. I'm just going to put the exercise on the screen and we can read through the exercise. And then we can move on. So suppose you're writing a function called average that calculates the average of the numbers in a list. What preconditions and postconditions would you write for? Compare your answer to your neighbor's answer. So what you can do now is compare your answer to the actual solution that they give us. Remember, these are just, a solution. These are not the alpha and omega solutions. The solutions they give us here is also just a sort of answer. So a possible precondition is assert that the length, the input list, should be bigger than 0 or greater than 0. If not, it will tell you that the list length must be non-zero. A possible postcondition is assert that numpy.minimum or input list should be smaller than or equal to the average, or smaller than or equal to the maximum of the input list. So the average should be between minimum and maximum of the input values inclusive. So those are possible pre and post conditions, but you might have others as well. A number of cars, the function get total cars returns the total number of cars. So get total cars 1, 2, 3, and 4. Output is 10, and then get total cars A, B, and C, you get a value error, invalid literal for integer with base 10 A. So explain in words what assertions in this function check, and for each one, give an example of input that will make that assertion fail. Now, if you look at this function here, the get total of values, then you assert the length of the value should be greater than 0. For the element in values, assert that the element must be integer. Values equals to integer element for element in values. And the total equals sum of the values. So assert that the total must be larger than 0, and then you return the total. Now they say in words, what's the assertions in this function check? The first assertion checks that the input sequence values is not empty, and an empty sequence such as just an empty sequence will make it fail. The second assertion checks that each value in the list can be turned into an integer. Input such as 1, 2, then C and 3 will make it fail. So in other case, anything that's not an integer, like a string, will make it fail. And the third assertion checks that the total of the list is greater than 0. So the input with a minus 10, for instance, will make it fail, because this only counts the number of cars. So you can't have a -1 car or minus 10 cars. Okay. So the next part and the last part of this workshop is debugging. Now, what does debugging mean? Debugging is what we call it when you have an error. We also call an error a bug. For instance, in this assertion error, that's a bug that you have to fix. Where it comes from, it's just a little bit of trivia. The reason that we call it the debugging is in the old days when they massive computers that stood in a room, took up a whole room, they physically had to go and take out the bugs, like the bees and stuff that got into the computer to make it work again when it went down. So that's where the debugging comes from. Okay, so some of it we've already done, but things to remember is know what your script or know what your program is supposed to do. Answers like my program doesn't work is not good enough for the scientific community. You have to know why it doesn't work. So in order to diagnose and fix your problems, you need to know what output you wanted. Okay, so it is quite easy for somebody in the commercial environment to know exactly what the output should be, but it's not that easy if you're a scientist and you're writing scientific code where you actually test a specific hypothesis or a specific experiment's outcome. So you don't necessarily have that luxury of knowing exactly what your output should be, but you know in what way the output should come. So what we do in the scientific environment is test it with simplified data. So before you're doing your real statistics and your usual massive data set, test with simplified data, test with a smaller subset of your data, test with fake data to make sure that the output is actually correct. Test a simplified case. So instead of having the whole data set there, have something small, a simplified case to make sure that you know that your code actually works. Then they say here compare to an oracle. Now an oracle is something that can be trusted, somebody that knows what you're supposed to do, using a previous program, for instance, an expert, somebody with expert knowledge in your environment, that is seen as an oracle. Bounce some ideas off them, ask for some help, and see how your data should look actually. And then check your conservation laws. For instance, look at physics, the laws of physics. If your program defines the laws of physics, it should work. If it defies the laws of physics, then obviously there's something wrong with your program. So look within your environment. There are some laws in place in all of the different scientific environments. So make sure that you stick by those laws, you don't override those laws. And then visualization. Visualization is something that we did quite intensively in the last 2 days. It helps you to visualize your data to see if there's something wrong with your data. Is to see if your output that you get is something that can actually be positive or something that can actually help and work. Okay, so then something that I mentioned previously, they call it make it fail every time and make it fail fast. Now it sounds weird if you're a novice programmer, if you've never done programming before, but make it fail every time is something to test if your program works properly. There's it's actually something that in today's environment you can't say out loud anymore, but there's a thing that they say is it's easy to write a program, it's difficult to make the program idiot proof. Now sometimes the idiot is the person programming the program, which you put in your own bugs into your software which you actually don't know about. So you can only debug something when it fails. Now if you get something to make it fail, enter wrong data, enter assertions, put in assertions that you know will work. What we normally do is make it fail so that you can take that failure and write your program in such a way that that failure will not occur anymore. Okay, so it's always good to make sure that your program can fail in certain areas and make it fail so that you fix your mistakes. Then they say make it fail fast, which means that if it takes 20 minutes to fail, it takes you 20 minutes to sit there for 20 minutes and wait for your program to fail. So it means that you have less time to spend on fixing it as to more time sitting and waiting for it to fail. And then you might lose focus and you might lose interest and so on. So make it fail fast is the idea that the smaller the gap between the cause and effect is, the faster you can fix it and the better your time spent will be. Then we talk about change one thing at a time, meaning that don't go and fix every single error that you see. Maybe you see a 20 deep traceback. Don't go and fix every single one. Fix one at a time and see if your traceback becomes smaller and smaller. Because a lot of times when you go and fix all of them at once, you don't necessarily exactly know what you did and how you did it. And sometimes your version control is not up to standard, and then you can't remember what happened and why you went wrong. Okay, so fix one thing at a time and remember version control. That's something that you always have to do. So keep track of what you've done. Make sure that you did the version control part before we did the Python part. So if you have a big piece of script and you want to change it a little bit, make sure that you keep different versions. There's a thing in data science that we call keep your raw data raw. Never change things that you know is supposed to stay exactly as is. Now, if you know it's something small, go and change it, no problem. But if you know this is gonna augment your program in such a way that you might want to come back if something went wrong, please make sure that you keep track of what you've done wherever whenever you go. And then something that a lot of us struggle with is be humble. Ask for help. Search for help. If you haven't fixed your problem in a few days or few hours, few minutes, depending on what type of problem it is, go and ask someone. Say, listen, I know you're also programming, you're also doing this. Please, can you help me with this? I'm struggling with this piece of this program. Things like the Python community, Stack Overflow, for instance. There's a lot of forums out there. There's a lot of people with vast knowledge in programming. And you can always ask anybody, wherever you go. Asking is one of the biggest things that we need to go forward. So there's a saying that ask a question and you might be a fool for 10 minutes. Stay quiet and you'll be a fool for the rest of your life. So be humble, go and ask somebody to help you. Okay, so that's it from my side. It's a little bit earlier than the other days, which is actually quite nice because I know your brains are tired by now, and the cognitive overload is quite a lot at this moment. So thank you very much for the week. Renee, thank you very much for everything that you guys did to make this happen and get everybody on board. Yeah, that's it from my side. I don't know if anybody else has anything to say or any questions. If you want access to the data or access to anything from this workshop and you cannot find it, you're more than welcome to send me an email. I'm just going to stop my share here. You're more than welcome to send me an email anytime, any place, not only with regards to this workshop, but with regards to anything carpentries. Data science, data carpentry, software carpentry, library carpentry, anything. Just send me an email.
Thank you very much, Martin, for I would really appreciate it. Thank you. Keep up.
Thanks, man.
Awesome.
Okay, so that's it from my side. Wish you all a great day further and a nice weekend, and stay safe.
Thanks, man. Like the same to you.